Okay, this video is going to talk about combinations and factorials, and truthfully, they are not directly tested or discussed in AP statistics. So you may be asking yourself, why are we doing it if it's not particularly discussed? First off, it's in every single college class when they talk about probability, so that's one reason. And the other reason is the combination is the introduction or the very first part of the binomial formula. And so it's very important to understand what is actually going on. So we're going to take just a couple minutes to show you what a factorial is and also talk about how to calculate that. And we're also going to show you how to do some combinations. So first off, factorial is the product of integer and all the positive integers below it. So if we had 5 factorial, we just write, and 5 factorial just means this, because it doesn't show very well, is 5 exclamation point. It's 5 times 4 times 3 times 2 times 1. And at 8 factorial, or at 8 exclamation point, is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, you can imagine that that would get very cumbersome if you had to write all that out. The calculator does it very nicely for you. So if I wanted to do a 5 factorial, hold on just a moment, I'm going to try to adjust my lighting so we'll get a little more light on the calculator. There might be a little bit better, I don't know. We'll see in just a second. So if I had 5, if I press the number 5, apologize for that interruption, but it's trying to adjust the lighting so we can see the calculator a little better. But we see 5, and if I just push math, arrow over to the word probability, and drop down to number 4, which is the exclamation point, that's telling me it was a factorial. So that gave me 5 factorial, and I press it out, and it went 5 times 4 times 3 times 2 times 1, which gave me 120. Also, if I tried the 8, I just press the 8 and press the math button, arrow over to probability, and drop down to number 4, 8 factorial, and enter. And all of a sudden you start to see you get some very large numbers very rapidly, okay? 0 factorial is equal to 1. So 0 exclamation point is equal to 1. So then we get into combinations, and this is where it's going to relate to the binomial, and we'll start talking about the binomial in a day or so. So combination, a subset or selection of a group in which the order does not matter. If permutations order does matter, we don't discuss them in AP statistics, and we often express it in n choose k. And we will show it by this notation, where this is the sample size and this is the number of things we're selecting. And just to relate it to the binomial, this is what it's going to look like. 8 choose k will be in the front, or n choose k. And this means n factorial divided by however many things we want, minus by what's not what we don't want, okay? So how many subsets of 3 can be chosen from a group of 5? So that would be written 5 choose 3. Sometimes it's notated 5 choose 3 like that. And it means 5 factorial, and then over 3 factorial over 5 minus 3 factorial, which is just 2. So this should have had a 5 here. This would be 5 times 4 times 3 times 2 times 1. Over 3 times 2 times 1 times, in parentheses, 2 times 1. However, we can make this a lot easier on the calculator. So let's take a look at the calculator so I can get it into the right proper lighting. We wanted 5 choose 3. So I need to press the 5 first. So 5. And then I'm going to go math, arrow over to probability, drop down to number 3. So it looks like 5 choose, there's 3, and there's our answer, okay? So in this case, there's 10 combinations that resulted, 10 different combinations where order didn't matter, where we started off with 5 and we wanted to choose groups of 3. So consider this. You have 4 people, Aaron, Bob, Karina, and Daniela, that we all call A, B, C, and D just to make it easy. All right. So we want how many groups with 4 people? Well, that would be 4 choose 4. So once again, 4, math, probability, drop down to number 3, 4 choose 4. There's only one group because basically we're choosing all of them. Now you could have chosen Aaron, Bob, who knows who you chose for first, but order didn't matter, so it didn't impact it. Keeping the same group, what if we only wanted 3? Well, we could have these ABC, BCD, CDA, or DAB. Those are completely different groups. And we want to choose 5. I mean, we have 4 and we want to choose exactly 3. So we press the number 4 on the calculator. And then math, probability, happens to be 3. It's like there's 4 different combinations, and here are 4. Mathematically, it would be 4 factorial over 3 factorial, and then 4 minus 3 is the 1 factorial, which is just 1. So 0 factorial and 1 factorial are the same. If we wanted 2 groups, we could have AB, AC, AD, BC, BD, or CD. And we look and go, you know what? That's 6 different combinations. And once again, we go 4, math, arrow over to probability. And we choose the number 2. And there's our 6 combinations. And lastly, if we only wanted 1, it'd be 4 factorial over 1 factorial. 4 minus 1 is 3. So this would be our formula. And 4, math, probability, number 3, followed by 1. There's our answer. Okay. So that's the basics of combinations. We'll do a couple on the other sheet and continue on. This moves fairly rapidly. All right. And once again, this is not on the AP exam, but it is part of the binomial formula, and you'll see that in a couple days. All right. So you're making a sandwich. How many different combinations of 2 ingredients can you make from cheese, mayonnaise, and ham? That sounds pretty awful. So basically, we're basically saying 3 choose 2, because this is what we're going to write it for the binomial. For the calculator, they like to think of this 3 choose 2 like that. So let's show this on the calculator real quickly. And we go 3, math, probability, number 3, choose 2. We have 3 possible combinations. All right. How many combinations of all 3 ingredients? Well, 3 choose 3. We should only get 1. So 3, math, probability. Oops. 3, math, probability, drop down to number 3. Well, that's not working very well. 3, math, probability, drop down to number 3, press enter, and 3, and we get 1. All right. An election ballot asks voters to select 3 commissioners from a group of 6 candidates. In how many ways can this be done? So we want to choose, we have 6 people, and we want to choose 3. So we're looking at 6 choose 3. So 6 factorial, there's my n, and this is my n minus k. So 6, math, probability. And there we have 20 possible combinations, which is actually a lot when you consider that you're only working with 6. All right. A 4-person committee is to be selected from an organization's membership of 11 people. How many different? So we have 11, 4, which again on the calculator is going to look something like this. 11 choose 4. All right. So 11, math, arrow over to probability, enter, 4. 330 combinations. You're on your way to Hawaii, and of 15 possible books, your parents say you can only take 10. How many different collections of 10 books could you take? All right. So once again, on the calculator, that's going to look like 15, choose 10. So 15, math, probability, 10, 3003. There are 12 standbys who hope to get on your flight to Hawaii, but only 6 seats are available. So how could this be chosen? Well, we have 12 choose 6, which again on a calculator is going to look like this, 12 choose 6. Oops. So 12, math, probability, and 6, 924. And to win the small county lottery, one must correctly select 3 numbers from 30 numbers. The order in which the selection is made does not matter. How many different combinations are possible? So we have 30 choose 3, which again on a calculator is going to look like this, 30 choose 3. So 30, math, probability, choose 3. And we have 4,060 possible combinations. All right, so that's the idea of combinations, and you'll see that more in about 2 days when we tie it to the binomial. Thank you.